Hi folks, today's topic is approximating and simplifying square roots. Our goal is to be able to recognize the perfect squares and then to simplify numbers that are underneath a square root, whether those are perfect squares or not. And that's the back that we're going to talk some more about simplifying. So let's start off by talking about what the perfect squares are. So I'm going to encourage you, let's see how far you can go. Pause. We've already talked about the perfect squares when we did factoring, when we talked about dopes. But let's see if you can do this on your own. See how far you can get on your own. All right, let's see how you did. So I hope everybody can at least get to 12. That's kind of my goal. So 1 squared is 1, 2 squared is 4, 3 squared is 9. See how that goes? 1, 2, 3. So the fourth one will be 4 squared. 4 times 4 is 16. Then we go to 25, 36, 49, 64, 81, 100, 121, 144, comma. Now, I would hope everybody can get there. Just a reminder, if you want the 73rd perfect square, you would just take 73 and square it. So like the 10th perfect square should be 100. Let's see if that's true. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 perfect square. Okay, so the next two I remember because they have the same numbers. 13 squared is 169, then it turns into 196 for 14 squared. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And then everybody should get 20 squared. It's 400. Okay, so these are the perfect squares, which means when you square root them, that's what this symbol is. The square root is called a radical. When you square root those numbers, you get whole numbers. You get nice numbers. So let's go through and square root each one of these. So the square root of 121. Now, if you can't just tell by looking, okay, this is a list worth memorizing, at least through 12. You know, like you can see a number and tell if it's even or odd. Those from your days of elementary school. Maybe in middle school or above, you started to recognize different multiples, you know, multiples of 7 or multiples of 5, multiples of tens for sure. You learned that in elementary school as well. So there's some famous lists of numbers. This is a famous list. When you see the number 36, you should think that's even. You should think that's divisible by 9 and 4 and things like that, but you should also see that that's a perfect square. So I expect pre-calc kids to already know their perfect squares. And if you don't, learn them. Memorize them at least through 12. All right, so 121, that's 11. Pause here. So I figured that out because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the 11th one in my list. It's also 11 times 11 is 121. So when I square root 100, it's basically saying what times what is 100. 10 times 10 is 100. So we just write it down once. The square root of 100 is 10. So pause here and fill in the rest. Let's see how you did. 7, 9, square root of 16 is 4. Square root of 196, that's the bigger of those two, so that's got to be 14. Square root of 1 is 1. There's one other number that's its own square root. See if you can remember that or figure out that number. Square root of 25 is 5, 8, 2, 6, 15, 12, 13. And there it is, the only other number who's its own square root. The number 0. Now we take off all the negatives. Remember, those negatives create those imaginary numbers that we talked about back in Algebra 2, which we will talk about again in Unit 2. I think it's Unit 2. It might even be Unit 1. I never always get it mixed up. Anyway, approximating a square root. So without a calculator, estimate the value of the given square root. So for instance, 116, that's not on our list, but it falls between 100 and 121. That means that the square root of 116 falls in between the square root of 100, which is 10, and the square root of 121, which is 11. And so this is an approximation, so we're going to use that approximately symbol the squiggly lines. And so 116 is a little bit closer to 121 than it is to 100, so I'm going to guess that it's closer to 11. It's actually, I'm going to say quite a bit closer. It's only 5 away versus 8, so I'm going to say 10.8. That's going to be my guess. Now, of course, we can do this on our calc. The square root button is above the squared, second square root of 116. Dang it. Let's try again. Second square root of 116, 10.77. So with rounding, took me up to 10.8. So what I'd like you to do now is, without a calculator, go through and make an approximation for what you think these are. And then I'll go through after you pause, and I'll go through and tell you what they are. All right, let's see how many you got within. You have to be, you got to go 1 decimal point and see how many you get correct. This turns out to be 12.4. I'm going to go through and do all my approximately's right now. Now, I didn't do this in my head, of course. I did this on a calc. So 14.6, 8.1, 2. If anybody got that one wrong, you got to pick a new class. 8.2, 4.8, 14.9, 7.5, 11.4. Now, if you're just copying down what I'm writing, you're kind of missing the whole point of this activity. You should be estimating, pause, and estimate what these are. They fall between 2 nice perfect squares. If all you're doing is writing down what I'm writing down, you kind of are defeating the purpose of this whole example. 9.9, 9.4, 7.9, and 3.7. So put a little check next to the ones that you got right on the money with 1 decimal point, and any that you missed, no biggie. Just as long as you're in the neighborhood. As long as you got basically the front number right, and I would say within a couple decimal points, I'd be content. All right, now the big part is to be able to simplify a root. So in this course, every fraction that you see needs to be simplified. I'm not going to say on there that answers need to be simplified. It's just a standard rule in this class. Same thing with roots. If you have a root that can be simplified, you must simplify that root. So what we tried to do is, when we were going to take 108, we're going to try to break it down into as many. First of all, it's not a perfect square. So 108 falls between 100 and 121, so it's not a perfect square. So what we're going to try to do is, we're going to try to factor it into a perfect square in something else. And then once we find that perfect square, we're going to have that part escape. So I usually start off by trying to break down 108 by the perfect squares. I start small so that I don't miss any. So 108 divided by 4, yep, 4 works. So I'm going to write 4 times 27 over here. But because 27 isn't prime, and is there a perfect square that goes into 27? If you can tell, you know you got to keep going. If you can't, just keep going through the list of perfect squares. 108 divided by 9, so that's 9 times 12. 108 divided by the next perfect square, which is 16. Nope, that doesn't work. 108 divided by the next perfect square. We know this won't work, but I'm just showing you how I'm going through in order. 108 divided by the next perfect square, and because this is prime, I know that's my best choice. 36 times 3. Notice, I didn't do 108 divided by 2. I don't care about dividing by 2 because 2 is not a perfect square. I went through my list and I divided only by perfect squares because that's what we're trying to find. So I'm going to use that to rewrite now 108 as 36 times 3. What's underneath the square root? 108. What's underneath the square root? It's still worth 108. But now it's organized in a way that I can have stuff escape. In other words, the 36 can get square rooted. So when you square root 36, you get a 6 that's free, but the 3 is not free, and that's stuck in the jail. Now, because we found the biggest one, we don't have to keep going. 3 is a prime number. There's no perfect squares that go into 3 besides 1, but it's not going to make it look any nicer. Let's say that you tried it and you just found the first one and you went with that one. Okay, so your first guess was 4 times 27. So I've got 4 times 27 underneath the square root. The 4 escapes and becomes a 2. The 27 is still inside. This is not good enough. It's kind of like when you were in probably upper elementary school and you had something like 24 over 16. When you divide 24 by 16 and then you write 12 over 8, that's not an acceptable answer. You have to break that down. Show you what I'm talking about. Let's say you had 24 over 16 as a fraction. Well, you would clean that up. Let's say you divided both the top and the bottom by 2. Yay, I'm done. I simplified it. No, you can simplify it more. 4 goes into both of those, and so I get 3 over 2. That would be my full credit answer. Same thing with this. You broke up. Yeah, 4 and 27. This is now nicer mathematically than that. But you are not simplified all the way because there's a perfect square that goes into 27. So 2 times the square root of what perfect square goes into 27? 9. So now from here, the 2 is still the 2. That thing is free. It's on the outside. 2 times. Now, what's the square root of 9? The square root of 9 is 3. And then the other 3 is not out of the root. It can't escape. And so that's still a square root of 3. What do you notice? 2 times 3 is 6. 2 times 3 is 6. Well, that's 6 root 3, which is what we got right there. So we could still finish this off. So I don't care which way you go about it, as long as you get to the right place. I always look for the biggest perfect square because I'm not going to give you some massive number. It's always going to be something relatively easy to find. So I just go and try to find the biggest one. If you don't, that's fine. You just got to keep breaking it up as you go through. Okay, so that's it for notes. You've got 13 problems for homework. Answers at the bottom. Good luck.